Hi everyone, today is May 5th and we're going to be graphing tangent and cotangent, secant and cosecant, okay? And we're going to use transformations, okay? All right, so we're just going to jump right into examples, okay? So example one is describe the graph of y equals negative tan of 2x in terms of the basic function. And so in this case, the basic function would be tan x, okay? So what do we need to do to tan x? Well, this negative out in front of the tan is multiplying tan by negative. Now that's equivalent to multiplying all your y coordinates for tangent by a negative value, okay? So if you multiply your y's by a negative, that's gonna make positive y's become negative ones and negative ones become positive ones, okay? So that's gonna be a reflection over the x-axis, okay? So y equals tan x, if we wanna describe this, which we do, okay? If y equals tan x is reflected over the x-axis, and okay, something else has happened. Okay, that 2. Now our b is 2 and it's multiplying the x, right? What that means is all horizontal distances are not, we're not going to multiply them by 2. We're actually going to half them, okay? So if we're going to half our horizontal or half of our x's, that's going to cause them to become smaller, which would be a horizontal compression. So and is horizontally compressed by a factor of 1/2. Okay. Now we're going to use that fact to help us graph this. Okay. So I want to do this. This one doesn't have very many points to plot, and they're not very nice. Okay. So all you really have is vertical asymptotes and zeros. Okay. So I'm going to have to do tangent and cotangent slightly different and teach it to you slightly different. Okay. So the very first thing, I want to just look at the basic tan function, okay, and talk about that one first, okay? So y equals tan of x. Now that x represents the angle that we rotate, and this y represents the ratio we get out, okay? Now when we're taking tan of an angle, the definition of what tangent in is that circle, right? And it's the y coordinate over the x coordinate of a point going around that circle that we've talked about, okay? Another way of saying this, okay, and I've shown you this in an earlier video, that tan x can be rewritten as sine of x over cosine of x. This is going to be a bigger deal when we next unit that we're going to talk about when we do trig identities and trig equations, okay? So tan x can be replaced with sine x over cosine x, okay? Now, I'm going to go back to when we did rational functions, because this has now become something that's rational. It's a fraction, right? So we had vertical asymptotes when this became 0, right? When this denominator, okay? So that's still going to happen, okay? So we're going to have vertical asymptotes at, or when, I should say when, not at, when cosine of x is equal to 0. Okay, so we can figure that out kind of quickly, okay? So this is going to happen when we talk about the circle, when cosine of x equals 0, that's going to happen right here and also right here. Okay, why? Because this point right here on the circle, if we rotate around it, the x is 0 and the y would be 1 and your r would be 1, right? And down here, it would be x would be 0 and y would be -1. Okay, now what are the angles? Now we could rotate this way, okay, and that would be pi over 2. Or we could rotate this way, and that's clockwise, right? And that'd be negative pi over 2. So we would have vertical asymptotes. If we land here or here is where we're going to have vertical asymptotes, okay? So that means x would equal plus or minus pi over 2. Okay, if we keep going this way, that'd be positive 3 pi over 2. If we go this way, negative 3 pi over 2. So plus or minus 3 pi over 2. We could keep going around, and if you notice, it's every odd pi over 2. So plus or minus 5 pi over 2. Okay, so let me count by pi over 2. So pi over 2, it's not going to happen at 2 pi over 2. It's going to happen at 3 pi over 2. It's not going to happen at 4 pi over 2. It's going to happen at 5 pi over 2. It's not going to happen at 6 pi over 2. We're not going to have what I'm saying is that we're not going to have a vertical asymptote at 6 pi over 2, but we are going to have one at 7 pi over 2. Now that's rotating in a positive direction. I could do the same thing in a negative direction. So that's why this is plus or minus 7 pi over 2. And we could keep going with that, right? So that's where all the vertical asymptotes are going to be for tan x, plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, okay? Zeros, which is x-intercepts, okay? Zeros are going to happen when sine of x is equal to 0, okay? So when is that going to be 0, okay? Well, if we think about that unit circle that we're going around, right? This is the sine is the ratio of y over r. So the only time that the sine ratio will be 0 is when the y coordinate is going to be 0. And that happens right here at angle 0, at angle pi, angle 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, and so on, right? So this would be 1 comma 0. And this one right here would be negative 1 comma 0. Okay. So what are and we could, that was, when I was just doing this, I was doing with positive angles, right? But we could also do this with negative angles, right? So 0, negative pi, negative 2 pi, negative 3 pi, negative 4 pi, right? Okay, so this x, what would cause this to happen is when x is equal to 0, plus or minus pi, plus or minus 2 pi, and plus or minus 3 pi, plus or minus 4 pi, and so on, right? Okay, so let's talk about what's going to happen if we try to graph y equals negative tan of 2x. Okay, now what's this 2 going to do? Well, these are all x's, right? So this 2 tells me I'm going to have to half all of these. So this one's going to have, when I graph y equals negative tan of 2x, we are going to have vertical asymptotes at x is equal to, and it's going to be half of each of these. So half of pi over 2 is plus or minus pi over 4. Half of 3 pi over 2 would be plus or minus 3 pi over 4. Plus or minus 5 pi over 4. Plus or minus 7 pi over 4. And there's a whole bunch more, okay? Now, this one's going to have zeros at half of all of these, okay? So that'd be x is equal to half of 0 would still be 0. Half of plus or minus pi would be plus or minus pi over 2. Plus or minus 2 pi over 2, which would be plus or minus pi. Plus or minus 3 pi over 2. And plus or minus 2 pi, because that'd be 4 pi over 2. And you can't see this. Dang it. Let me slide that up for you. Okay, so we have zeros at, like I was saying, okay, so what I'm doing is to get these, I'm just taking each of these, I'm taking half of it, okay? So half of 0, 0. Half of plus or minus pi is plus or minus pi over 2. Half of plus or minus 2 pi would be plus or minus pi. Half of plus or minus 3 pi would be plus or minus 3 pi over 2. And then half of plus or minus 4 pi would be plus or minus 2 pi, and so on. Sorry, you couldn't see that. Okay, so now we can put in all the vertical asymptotes and all the zeros, okay? All right, so I'm gonna come up to my graph, okay, and I know right here is pi, and I'm going to count how many lines there are to pi. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 lines to get to pi. That would mean each of these is pi over 8. Okay, so this would be pi over 8, and then this would be 2 pi over 8. But 2 pi over 8 is really pi over 4. And what do we know? We have a vertical asymptote there, right? Okay, so we have a vertical asymptote at pi over 4. So we have one right here. So I'm going to draw that in. Okay. I have one at 3 pi over 4. Okay, so this would be 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, but 6 pi over 8 is really 3 pi over 2. Okay, so we have another vertical asymptote right there. Okay, and then we don't have any more because the next one would be at 7 pi over 4, and right here that's 4 pi over 4, so it's past that, or 5 pi over 4, sorry, 5 pi over 4, and that's past this one. Okay, now how about the other side? Okay, so we have another one at negative pi over 4. So basically every 4 grid lines we're going to have a vertical asymptote. So once you've established the distance between 2 of them, that distance is going to stay the same between vertical asymptotes. So there's 4 grid lines, right? So the next one would be right here. Okay, and then we also know we have zeros. Well, we have a 0 at x equals 0, so that's an x-intercept. We also have one at pi over 2 and at negative pi over 2. And then we have one at pi, and then we have one at negative pi. Now, here's the problem. We can't really tell the shape from this because all we have is vertical asymptotes and x-intercepts. So we can't really tell the shape. So we have to think a little bit more, okay? We know what the tangent function looks like, okay? So normally we would start down here on this vertical asymptote that's to the left of the y-axis, and we'd come down here and we'd start right here and come up and go through this point and graph it and come this way, right? Because that's what tangent does, right? Okay, that's the shape of the tangent curve of one little segment of it, okay? Now, what do we know has happened though? We have a reflection over the x-axis, right? So now, because this part is above, this part is now going to be below, and this part that was below is now going to be above. So really, one of these is going to look like this, and it's going to come down through the 0 and then come down. And I kind of bent that a little too much. Okay, and then the same thing's going to happen. So we're going to, and then it just repeats, right? And really, see, here's the difference. The tan function repeats every pi. It has a period of pi, not 2 pi. Okay, so we're going to come down through this point and then down along that vertical asymptote. And then same thing here with this one, but it's not going to be a full complete one. It's going to look something like that. And then this one. So once you've established what one of them looks like, all of them are going to look the same. And then this one is just going to come down. Okay, so that's what y equals negative tan of 2x is going to look like. It's going to look like this. Okay, the general shape of it. Okay? So what's important is that you realize what is causing the vertical asymptotes, okay? And it's when this cosine of x is equal to 0, okay? And then what does this 2 cause? That causes all of the normal vertical asymptotes and zeros to be half of what they normally are, okay? And then the reflection happened, right? Okay? So you can do it this way, all right? Okay? Let's go to the next example. So for this example too, we want to describe the graph of y equals -2 secant of x over 2 in terms of basic function, okay? So in terms of secant x, okay? So what do we know is going to happen here? So y is equal to secant x. That's the basic function, okay? What does the negative do out here? Well, that's going to cause a reflection over the x-axis because it's going to change the sign of our y's, okay? So y equals secant x is reflected over the x-axis, okay, comma. This 2 is going to cause something. That's going to cause a vertical stretch by a factor of 2. So it is vertically stretched by a factor of 2, comma. Okay, now this dividing by 2 is the same as multiplying by 1/2. Okay, so my b is 1/2. Okay, maybe I'll write that. B is equal to 1/2 because dividing by 2 is the same as multiplying by 1/2. So my b is 1/2. Okay, what's the reciprocal of 1/2? Well, it's 2. So I'm going to take my x coordinates of any point on y equals secant x, and I'm going to double them, right? I'm going to multiply them by 2. Now, what in essence does that do? It's going to make the x coordinates become bigger because you're going to be multiplying by 2. That's going to cause a horizontal stretch by a factor of 2. So then we add to this and horizontally stretched by a factor of 2. Okay, now I'm going to do this. I'm going to do this using cosine x. Okay, so we're going to do this with the 5-point method. Okay, because secant x and cosecant x are both just reciprocals of sine and cosine. Okay, so we're going to use those. Okay, to figure this out. Okay, so first of all, let's do y equals. Let's talk about the 5 points for y equals cosine of x, right? Okay, so we've graphed cosine x a lot, okay? So we know when angle is 0, right? This ratio, when angle is 0, the ratio is 1, right? Or 1 over 1. I'm going to write it as 1 over 1, okay? And then the next point is pi over 2, comma, 0 over 1, okay? Now, we normally don't write 0 over 1, we write 0, okay? But we're going to do a reciprocal. That's why I'm writing these as fractions, okay? And then pi. Pi, when we put pi into cosine, we get -1, okay? But really that's -1 over 1, okay? And then that's the third point. The fourth point would be 3 pi over 2, okay? And that would be 0 over 1 again, because that's 0, okay? And then 2 pi, and we're back to, if we put 2 pi into cosine, we get back to 1, right? It's 1. That ratio would be 1 over 1. Now I'm writing these all as ratios, okay? Normally we don't, but I'm writing as ratios because I want to know the 5 points for secant x, because secant x is the reciprocal of cosine, okay? So remember, y is equal to secant x is equal to 1 over cosine of x. Okay, so this point at 0, 1, when I do the reciprocal of 1 over 1, it's still going to be 1. Okay, pi over 2. When I do the reciprocal of this, it's not going to be 0 over 1. It's going to be 1 over 0, and that's undefined. That's going to be a vertical asymptote. Okay, and then at pi, if I do the reciprocal of -1 over 1, it's just going to be -1. 3 pi over 2. Okay, when I do the reciprocal of 0 over 1, that's going to be undefined. That's going to be a vertical asymptote. Okay, 2 pi comma 1. So when I do the reciprocal of 1, it's just going to be 1. Okay, so these are the 5 points for secant x, okay? Anytime cosine is 0, you're going to get a vertical asymptote there, okay? So that's right here at pi over 2 and also at 3 pi over 2, okay? Everything else is the same, okay? All right, so now, okay, what happens under this transformation, right? So we have x and y's right here, right? For secant x. We have an x coordinate and a y coordinate. Under this transformation, what are we going to do to the x's, right? So the x's, what we're going to do is they're stretched by a factor of 2. So now our new x's are going to become, we're going to multiply our x's are going to all be doubled, and that will be our new x. Sorry, I got kind of tongue-tied there. Okay. And what are we doing to our y's? Well, they're reflected over the x-axis and vertically stretched by a factor of 2. So we're going to multiply all our y coordinates by -2. So we're going to take the x's, all these x's, and we're going to double them. And all the y's, we're going to multiply by -2. Okay. And so our points, our 5 points for y is equal to -2 secant of x over 2, okay? The 5 points are going to be, so we're going to double our x, so that's going to be 0. We're going to multiply our y by -2, so that's going to be -2 times 1, which would be -2. We're going to double our pi over 2, so that's going to be pi. Now, if we multiply our undefined term by -2, it's still undefined, okay? And then pi, we're going to double, so that's going to be 2 pi. And we're going to multiply our y by -2, so that becomes +2. And then 3 pi over 2 times 2 is going to give us 3 pi. And then when we multiply an undefined term by -2, it's still undefined. And 2 pi, we're going to multiply by 2, so that's going to be 4 pi. And -2 times 1 is going to be -2. So there's our 4 points or 5 points for the graph, okay? So we know right here, okay, this is going to be, this one and this one are going to be vertical asymptotes. And this one's going to be a vertical asymptote too. And then once we get a couple of these, you're going to start seeing where all the vertical asymptotes are placed, okay? All right, so we know we have a vertical asymptote at 3 pi. So that's over here at 3 pi. So I'm going to graph that vertical asymptote in. I also have one at pi. Okay, and I bet you could tell me, because these are going to be equally spaced, you could tell me where they are on this side, right? There's going to be one at -pi. Okay, so we're going to draw one at -pi. Because these are going to be equally spaced. And then at -3 pi. So I'm going to put my ruler down. Okay, then I have some points I can graph, okay? So 0, -2, that's this point right here. And then 2 pi comma 2, that'd be this point right here. And then 4 pi -2. Okay. So what I know is, remember the general shape of these are up U's and down U's, right? This one right here is normally an up U, but because of the reflection, it's actually going to be a down U. So it's going to look something like this. That's a non-technical term, down U, okay? So it's going to look like this. And this one's going to look like this. And this one's going to be half 1 going down. And okay, so now you can start seeing, okay, so this next one's going to be an up U, and so it'd be right in the middle and right here. And there's another one that's going to happen right in the middle here, okay, because there's going to be another vertical asymptote that we're not drawing, okay? So it's going to be here at -2. So this one's going to be an up U. And this is going to be half of 1. So something like this, and then this one continues going down that way. Okay. So what you're seeing is, okay, to right here, you're seeing 1 period, okay? All right. So you're seeing 1, 2, and actually I asked you to do 4 periods, but it's impossible with the grid I gave you, okay? You're only going to see 3 periods, okay? All right, guys? Okay. So just use the grid I gave you, and whatever I said, if I only want to graph 1 period, definitely graph 1 period. If I asked you to graph more, then go ahead and just fill the grid. And I pretty much gave you the grid space to do that on the graphs I gave you to do this on, okay? All right, you guys, so that's for tangent and cotangent, okay? You got to determine the vertical isotopes by that reciprocal function, okay? So tan x is sine x over cosine x, okay? And cotangent x is cosine x over sine x, okay? And whatever causes those denominators to be 0, that's when the vertical isotope happens. And then same thing here, okay? When cosine x is 0, right? When cosine x was 0, that caused a vertical isotope, okay, on the basic trig function, okay? All right, so I want you to graph these. I've asked you a few other questions that are gonna make you, it's gonna make you think a little bit and do a little bit of problem solving. They're not directly graphing these, okay? But using what I've taught you, you should be able to make the connection on how to figure out some of these numbers, like for the min and the max on the x-axis, okay? All right. Okay. So let me grab the assignment sheet and we'll put that assignment down. And when I pulled this out, I just realized I forgot to put yesterday's on there. Okay. So yesterday was the 4th. Okay. And we did this one, right? And then today we did GTF 6. Okay. And we have 2 more days in this unit, and then we'll start our last unit for the school year. Okay. All right, guys, that's it. I want you to do GTF 6 only tonight for homework. These when you were doing these were worth 12 points. Okay, so 4 points for the notes, 4 points for graphing the trig functions 4, and then 4 points for this assignment worksheet GTF 5. So each one of these was worth 12 points each. Okay, notes, the actual work, and then the practice graphing the trig functions. Okay, hopefully you're really good at graphing these trig functions now, and you don't even have to think about it. You just know where the points are. Okay, and you can kind of do it mentally. All right, that's it, guys, for today, and I will see you tomorrow. Tomorrow should be a fairly easy lesson too. Okay, take care, guys. Bye.